Friends, let's wait for 5 10 minutes and then we shall proceed further.
Hey, hello everyone. Are you guys able to hear me? Please, can you confirm over the chat? Please, can you guys confirm over the chat window? You can just chat, put a message. Yeah, sure. Rajwin Pao is able to hear me. Jazli Hizami. Okay, wonderful. Okay, so welcome everyone to this session on MLOps. And, you know, there are a lot of people who have registered, but I think because these are working hours in India, only a handful of people have joined, but I think from Malaysia, quite a few of them have joined. So let us understand what is MLOps and why do we need MLOps in the current world that we are living in. So that would be our discussion. We will understand what is MLOps, what is the need for MLOps, what are the various approaches, and tomorrow we shall discuss about Kubeflow, MLflow, TensorFlow Extended, and Airflow, and how these tools are revolutionizing the way machine learning algorithms are built and the way they are implemented. First things first. Why MLOps is becoming so famous, right? And what is ML ops, you know, at a high level? ML ops is a process, and this process is helping the organizations integrate data science, machine learning, and AI initiatives. It is extremely new, but the kind of demand basically has skyrocketed over a period of a few months. Just over the past few months, the demand has skyrocketed. I'm going to open Google Trends and then show you something interesting here. And I think I should be sharing the entire screen. Whatever I'm scribbling on the screen, let's Google Trends. And let me type MLOps. Let's look at worldwide. Let's look at the demand over the last 5 years. And look at what's happened. Huge demand for MLOps exists, especially in South Korea, Japan, Taiwan, Portugal, Singapore, Canada, India, so on and so forth. And AWS SageMaker. Yeah, that demand is also very high. Actually, you can use the SageMaker to some extent for MLOps purposes. Okay, or let me type Kubernetes. Or let me say, come on, let me type Kubeflow. And MLflow. Look at the demand, friends. Okay, and you have TensorFlow extended. But would it show exactly TensorFlow extended? No, I think not. Apache 8Flow. Wow, look at the demand, yeah? So, of course, this probably I would remove it. And let's compare these three only, which is MLOps, Kubeflow, and MLflow. Demand is humongous and demand is on the rise. Certainly, I have no doubts about that MLOps is going to be the future. Okay, demand for MLflow is increasing, and would it increase further? Yes. And research says that here there is no forecasting option, but research says that more than data science, the term MLOps is going to overtake data science in the next 2 years or so. Then you have ML engineer, machine learning engineer, okay, and you have data engineer. Okay, so or data science as a search term. So the data engineer as a search term, yeah. So still data science is there at its end, but ML engineer, data engineer are the kind of roles which are fast picking the attention of the world. So that's where we stand as of today. So MLOps is nothing but a process, demand for which is just skyrocketing. And ML ops, or this is also called as model ops. MLOps or model ops, it started in late 2019, 2018, 2019, late. And then it was COVID, all that. But there is also something called as AI ops, which people are speaking about, but don't get confused. ML ops is going to be a different concept altogether in comparison to AI ops, right? But it's all about ML ops. Now, typically we had our CRISP-PM module, wherein you understand the business problem, you have the data understanding, you basically prepare the data, you build a model, you evaluate the model, and then you deploy the model in production. And this process is going to go on and on. It is an iterative process. While this goes on and on, who are the various stakeholders who get involved? You'll have, when it comes to business understanding, you'll have subject matter experts who get involved. And then you will have data engineers. The job of data engineers basically is to acquire the data. So let me write it down here. Acquire data. And also they prepare the data preparation, data preparation. Then they perform feature engineering also. Feature engineering. Of course, I'm not saying data scientist does not get involved. Data scientist also gets involved. Right? And subject matter expert also gets involved. So there are three people predominantly who gets involved: data engineers, data scientists, and subject matter experts. So you have data preparation, feature engineering, model training, model evaluation, model training, and evaluation. Once you develop the model, what do? We have to prepare the model. So until model evaluation, I would cover all these: data understanding, prep, modeling, evaluation. All these guys do it. Once you develop the model, what would happen? You have to deploy it. For deployment, predominantly there are three phases when it comes to deployment. What are those three? Number one, you prepare your data for production. Number two, development to production. Number three, continuous monitoring and creating a feedback loop. What happens in preparing for production? You have to create a runtime environment. Where do you want to deploy a model? You do risk evaluation. What if I deploy in a specific server? Would it withstand the load? Would it give me the results with the speed that I'm expecting the results to come my way? And you'll have quality assurance. When it comes to dev to production, what will happen? You look at elastic scale, meaning as and how the number of users who are accessing my system increase, automatically my server has to support. Then you'll have containerization. Then you'll have CI/CD pipelines, continuous integration and continuous development. Then you have monitoring and feedback loop. Here, you have to have logging facility. You have to capture the logs. How much data is being supplied? How many new, for how many new instances did we do inference or prediction? So logging, alerting, alerting. Then you have something called as input drift tracking. I'll talk about data drifting, yeah. Performance drift. I'll talk about performance drift also in the subsequent slides. And then online evaluation. For performing all these things, typically people used to use DevOps engineers or DevOps people who are aware of DevOps. And here you will have data engineers and DevOps. And here for production readiness, you'll have data engineers, software engineers, and machine learning architects. And a typical data scientist will oversee a few of these spaces. Just based on the kind of things that I explained, you would be now thinking, oh my God, I thought the data science role is, or data scientist role is pretty narrow. But now you understand that data scientist gets involved in all of these phases, right? Heavily, MLOps concepts revolve around DevOps. What DevOps is for software projects, MLOps is for machine learning projects. So, key things about MLOps or DevOps basically. DevOps is for typical software projects, MLOps is for machine learning projects. Just remember that. And focus will be on having a robust automation and establishing the trust among the various teams. It brings in the idea of collaboration and making communication management robust. End-to-end service lifecycle is managed, like you build, you test the model, you release the model in production. And you prioritize continuous delivery. Both of these do that. However, DevOps cannot be immediately used for machine learning projects because deploying your software code into production is fundamentally different than deploying your ML models in production. There's a huge difference. Software code is really static. You need not change many things. Okay, so if you have a static code, easily you can maintain it and deploy. But when it comes to MLOps, ML models, these constantly change. They'll be very dynamic. Sometimes the input data itself changes. You might want to bring in new data altogether. Okay, these are the kind of things which keep happening. So on one side you have dynamic, data. Code is also static here on DevOps, but when it comes to MLOps, it's very dynamic in nature. So machine learning models are constantly learning and constantly adapting, in fact, to the new inputs also. Another complexity is when it comes to ML models are made up of two things: data and your code, both. Hence, MLOps is unique. Okay, next. MLOps, how is it going to actually help? MLOps in the first place is important for the data science team, even if you have one model in production, because you need to continuously monitor the performance of your model and you need to adjust your model accordingly. Okay, then sometimes you might get bad prediction. Sometimes your accuracy might decrease over a period of time. Sometimes your model might not even predict given the data. And sometimes you might not be aware of what skills are needed to handle the project end to end. All these kind of things would be addressed when it comes to MLOps. Because traditionally what happens is you'll have teams, data science team, and the job of data science team is to understand the business problem, get the data understanding, prepare the data, build the model, evaluate. When it comes to deployment, data science team makes use of software engineers or your IT engineers. And they are the people who deploy the model in production from here to here. Still, the question is, after deploying, who is going to monitor? Data scientists are costly. Would you use them to monitor? Not really. If you have this process automated, your data scientists can actually invest their time in what is best for your business. They'll be working more on enhancing the algorithms, improving the accuracy, and all that. And real assessment of your data science projects is not done in test environment, meaning you take the data, you split the data into training and test, you build your model on the training data, and then you test it on the test data. This is fine to hear, and it sounds practically perfect. But then, whatever accuracy you get here versus post deployment, what accuracy you're going to get might vary. So, you need to constantly keep monitoring your models in production. Okay, next. So your performance of models might really change the moment you deploy. So monitoring is so much more critical. Another major risk is that machine learning model performance is very sensitive. Slight change in the input data, your model might not work well. They tend to give you errors. Slight update in the packages or libraries, your model in production might not work. So you should be aware of these are all open source libraries that you use, basically Python. You use scikit-learn and bunch of those Python and various libraries which are used in Python are open source. So frequently there'll be version upgrades. So you would have built your model on certain version and then deployed. Another version gets updated, and then results will start deteriorating. So ultimately, pushing models in production is not the only step in machine learning lifecycle. So what should you do? That's just the beginning of monitoring process. You monitor the performance and ensure that it behaves as expected. As data scientists push more and more and more models into production, MLOps becomes critical in mitigating those potential risks. And it can be devastating for the business if things go wrong, right? If the predictions go wrong because of the drift in the data or because of the drift in the performance, then your businesses will get impacted negatively. And you also have something called as responsible AI. Responsible artificial intelligence. It covers two things: intention and accountability. Okay, two things: intention and accountability. Ensuring that models are designed and they behave in specific way is intention, and you're assuring that the data used for AI projects comes from valid data sources and unbiased data sources. So you need to have multiple checks to ensure whether your data is right or wrong, whether your model is being biased or not. Okay, and then you have accountability. Accountability means you centrally control, manage, audit the AI system. Okay, what data is being used, how is it coming, in which models are you using that, to establish the trust factor, because there'll be a lot of regulatory bodies which will be monitoring things, right? Especially in finance, life sciences, healthcare, and all that. So for that purpose also, you need something called as ML ops. You might feel until now that, wow, these are all theory, I know all these things already, right? But then if you are asked to demonstrate that your model complies with the regulatory norms, then you will face music. Okay, if I just ask you to show me on whether your model is complying with the regulatory norms or not, that's it. You'll fumble because you're not monitoring, right? Simple. End-to-end automation is a reality now, thanks to MLOps. Seamless integration, end-to-end. Okay. So, yes, these are all the various things which are the benefits. Now, MLOps will also help you to build your model at scale. Okay, what do you mean by that? When you build your model, maybe you're building your model, maybe your department, you started off with the model and you built, say, 10 models and you deployed them in production, you started monitoring. Your organization CEO is happy with these 10 models, and now he says that, okay, let us implement 100 models. Massive deployment, 1,000 models, massive deployment of machine learning models. Slowly from 10, it became 100, from 100 to 1,000. How are you going to monitor all of these? And a typical bank, supposedly, a well-established typical bank uses close to 400 to 500 models, machine learning models. How could you deploy those many? How would you monitor those many? How would you know those many are working well or not? Would you have your data scientists monitor those models? In that case, who will focus on building new models? So, at a bare minimum, MLOps helps you keep track of versioning, tracks the versions, various experiments that you're performing and all that. And it will help you understand whether retrained model is better than previous model or not. Okay, whether the retrained model is better than the previous model or not. And ensures that model does not degrade model performance, does not get degraded. It's a critical part of transparent process. If I were to put you in, put all these things, sum up all these things, then MLOps is in transparency into your senior management, and your senior management would be able to understand what's happening end to end. Okay, so that's MLOps basically, right? You're just operationalizing the model and you draw continuous inferences. Bringing your data, your model, your code, everything into a single realm is your MLOps all about. Okay, and you have various roles. When it comes to roles, you have subject matter experts, you'll have data scientists, you'll have data engineers. Okay. Then you have software engineers, you have DevOps people, so on and so forth. Sometimes you'll have risk managers, you'll have translators who will translate business into technical AI translators. Then you'll have ML architects, so on and so forth. What do subject matter experts provide you? They'll provide you with a metric that you need to meet. They'll say, hey, you're doing this project for this purpose. These are the metrics. These are the objectives that you need to achieve. They continuously monitor your project to decide whether the model that you're building is aligned with the initial needs or not, and aligned with business throughout. And from MLOps perspective, it will help you easily. How will it help MLOps? How is it going to help an SME? Easily, you'll be able to understand deployed model performance in business terms. Automatically, you can track all these metrics. You have a mechanism or a feedback loop for flagging the model results. If the model results are not aligned with your goal, easily alarm is raised. Okay, what does a typical data scientist do? Build a model, deliver the operationalizable model so that it can be used in production, assess the model quality. These are three things basically typical data scientist does. Build models, deliver operationalizable models, which is put in production, and assess model quality. And what does MLOps do? It will automate the model packaging and delivery for easy deployment to production. Okay, it will have the ability to develop tests to determine the quality of deployed models, and it makes continual improvements. You get visibility into the performance of deployed models. You can investigate data pipelines. All that MLOps will help data scientists do. Then you have data engineers. They optimize the retrieval and use of data. Simple. Retrieval and use of data. These are the two things that a data engineer does. And what does MLOps do and how is it going to help data engineers? It will give them visibility into performance of all deployed models. You will be able to, as a data engineer, see end-to-end data pipeline. And you'll be able to understand all the data plumbing issues, underlying issues with respect to connectivity and all that. Software engineers. Typically, what do? They take the model and integrate the model into the organization applications. If the company says, hey, I want a web application or a mobile app, they do that. Software engineers do that. And how will MLOps help them? Multiple people can work on the same application. Okay, when you apply MLOps, two people can work on the same application. Versioning and automatic tests are performed. And that's what software engineers extensively do. So both of that is taken care of. MLOps maintains the versions of the code and also automatic tests. Then you have DevOps. What happens in DevOps is basically you build operational systems. And you test for security, performance, availability on that. And you have CI/CD pipeline management. And MLOps will help you perform seamless deployment pipeline. It will help you build a seamless deployment pipeline. You can integrate MLOps very easily into your larger DevOps strategy. Risk managers will look at what is the risk if my model predicts incorrectly. Is it going to distort the brand image? Is my company, external image at stake? Is it going to, meet the compliance norms? All these things. And MLOps has automated reporting structure. Okay, and it will ensure that all these aspects which your risk managers need is automated. Then you have AI translators who translate, they are like kind of subject matter experts, but subject matter expert is completely from business. Data scientist is mostly from data perspective. AI translator looks into both business and data. Okay, and entire process of AI translator is automated. Finally, ML architects, they ensure that how do I make my model scalable? How do I make my model flexible? From design to development to monitoring, all these things. And what does a typical MLOps guy does? They have the ability to, MLOps will help drill down into data pipelines, entire data pipeline. It will help you drill down and then figure out where are the loopholes. Okay, to this extent, things are operationalized. So if you're thinking that building a model is just data scientist role, then you're wrong. Okay, let me give you a quick primer on ML. You have model development. The first step here would be establishing business objectives. Fraud transactions should be less than 2%. A simple objective to be met. Next thing is, you analyze what are the various data sources and perform exploratory data analysis. What relevant databases are available? Is the data sufficiently accurate and reliable? How can stakeholders get access to this data? What data properties can be available by combining multiple data sources? Will the data be available real time? Do I have the labels available to the data? What platform should I use? How will data be updated once the model is deployed? All these things. Okay, so, you also need to take care of personally identifiable information and not safeguard the data, so on and so forth. So, these are the things that you do. Then you perform feature engineering and feature selection. And feature selection. There are many things in feature engineering. You have feature selection, feature extraction, feature construction, so on and so forth. You take the raw data and transform them into features. Okay, that's what we do. And data cleansing is also a major part of your feature engineering, basically. Then training and evaluation. So you train and optimize your machine learning model in in an iterative manner. You test several algorithms. Okay, features can be automatically generated. Feature selections are adapted. Algorithm hyperparameter tuning. All these things fall in this step. Then reproducibility. You have a lot of experiments that you perform. Okay, the challenge here is when you perform experiment on data, can you replicate it? Can you reproduce the same results? And this true reproducibility requires version control. And then you have responsible AI. You need to reproduce the model, okay, which is part of operationalization challenge. Okay, and the DevOps team also needs to understand how to verify the model. There'll be regulatory norms, all that has to be abided with. There is documentation. Automated model document generation happens. Automatically required documents are also generated for audit purpose. Versioning is maintained. All these things can be end-to-end, automated. Okay, then this is model development process. Now comes productionalization and deployment. Here, what are the various model deployment types? And what are the various contents? Do you want to deploy the model as a service? Or as a live scoring model? Or do you want an embedded model? Model is deployed in a single framework. Okay, to provide something called as a REST API. REST API endpoint is what you call it as. This means, or the means from which this API, application programming interface, can access the resources it needs to perform a task. And it has to respond real time. Okay, what to be deployed? Okay, or what to be deployed models consist of depends on the technology chosen, but it will typically have code and data. Okay, and there are various things. To reduce dependencies on the production environment, you can export the model to some format. Basically, people export the model into PMML format or PFA format or ONNX format or POJO format, different formats. These aim to improve model portability between systems. If you have different software, different libraries that you use, still you'll be in a position to deploy the model. Whether or not to use a portable format is a choice to be made by us. And here is where containerization is coming into picture. This is increasingly becoming popular when deploying ML models, and container technologies such as Docker are very lightweight on virtual machines. It allows applications to be deployed in independent environments. Okay, and if you want to use multiple containers, okay, if you want to scale the model, right, elastically, you need multiple containers. See, in one container you have one model. If you want multiple containers, orchestrating those containers end to end is done using Kubernetes. What is Kubernetes? What is Docker? Both can be used on premise and on cloud. And then comes the next important thing, which is model deployment requirements. You need all the coding, standard documentation, sign-off standards, everything to be made available. How do you rapidly, automatically keep deploying the model in production, right? And how do you build CI, CD pipelines? Okay, all these become important. So model development, productionization and deployment, and finally you'll have monitoring. Once a model is deployed to production, now the critical component starts monitoring the performance. Not many people do this, and they run into a lot of issues. Is the model getting the job done quickly enough? Is it doing that real-time prediction if it's meant to do? Is it taking sensible amount of memory and processing time, etc.? Are a few things that have to be addressed. Data scientist, what does what does a data scientist really be concerned about? Data scientist, so one is your DevOps folks, one is your data scientist folks. They want to know whether the model is getting degraded in production or not. Okay, and is the model giving the desired results or not? These are the things which your typical data scientist would be concerned about. And ground truth. You predicted something. You predicted that next month sales will be $1.5 million. At the end of next month, is the sales actually 1.5 million, less or more? Ground truth. You are interested in that. You'd be interested in input drift, meaning initially when you built your model, there was say a specific variable called income, which was exponential following exponential distribution. After 6 months, the input called income changed its distribution to skewed. Complete change. You need to know that because your model might not work well. Your model that you built was for income variable, which was exponential. So is the model delivering value? Is the model giving the sufficient result or not? Okay. And finally, you'll have two more things. I'll just give the names and then we'll wind up, because I believe that this will be complete theory and not many people would be really keen here. Okay. So iteration and life cycle. This is one thing where iteratively you keep collecting the feedback about your model, and a feedback loop is introduced. And finally, governance. That's a key point. All the legal issues, etc., would be addressed in governance aspects. And within governance also you have data governance and process governance. Okay, these are the various things that one should be aware of. I know I scribbled a lot, but that's okay. So model development, productionalization and deployment, model monitoring, iteration, and the entire life cycle loop, governance. These are the things that one should be aware of. Okay. So I will stop here, and we will connect again tomorrow, and we will discuss a few more things about ML ops. We will primarily focus upon the how part of it. Okay. How do you develop the models? How do you typically, deploy the models? That's a core thing that we would be discussing, and that would be discussed in tomorrow's session. So I'll stop here, and thank you so much, friends. If you have any questions, please ask me. I'll give you a quick 3 minutes to ask me questions. Yeah, please ask me questions. I'll give you a quick 3 minutes. You can just put your question in the chat window. All right, friends. Thank you. Have a good day. Bye.